I also sit inside the Technical Support Centre based out of Manchester, looking after our Digitalised Automation Specialist team, providing both pre and post-sale support for our complete portfolio really within digital industries, but focusing around factory automation, motion control, so PLCs, HMI, SCADA and the likes. My details are on the screen now, so feel free if you want to connect with me or follow me. We do share some cool tips and tricks as well on these social media platforms. But this afternoon then, I am here to cover SIMATIC controllers best practice for you. So in the coming 45 minutes or so, I'm going to take us through a brief overview of some of the tools and support that is available for you when using our SIMATIC controller products. In particular, I'm going to be focusing on our published SIMATIC programming guidelines document and how that can be a benefit to you. And then for the remainder of the session, I will just be showing live demonstrations of how to implement some of these best practices into your application code to make sure that your code is optimized and the most efficient to ensure that you can get the best out of your machines and processes. There is a link on the screen there to further information, which essentially takes you straight to our support site and the most important topics page. Because for the rest of the presentation, I don't have any PowerPoint slides or anything to show you. There's nothing secret about what I'm about to show. It is all available to you right now for use to get hold of inside of our support site. So this is our support site up on the screen right now. The web address is simply support.industry.siemens.com. And through this web portal, you can gain pretty much access to any kind of information you would require with regards to any product within inside of our portfolio, be it the manual, be it an FAQ, the CAD data, the technical spec sheet, maybe an application example of how to set something up. All this information is available online at this portal. And what I would like to do is just highlight to you this link here on the left-hand side. Underneath Quick Guide, it says Important Topics at a Glance. And this really is a top link to follow. If you click it, it will take you to this page here, which is basically a collation of all the most relevant information on the support site, or hopefully the most relevant information to you under our different categories, be that for TIA Portal, our visualization systems, control product range, motion control, safety, process automation, virtual tools. All the top links are available for access from this one page. And I do recommend clicking it and having a quick check out to see what you might come across. Clicking the TIA Portal link at the very top of this, which is what we're focusing on today, brings you to this page, which is our overview of the most important links for TIA Portal. Again, from here, you can filter the TIA Portal selection to say whether you're interested in the controller side of life, visualization, or maybe safety or even migration into TIA Portal. Clicking these links filters it for you. And you can see how it is the go-to place to get anything you might want. You know, directly from here, we've got the downloads for TIA Portal. Of course, all of our software is available to download for free from this support site. And if you don't have a license, you can just use the 21-day trial to start getting up to speed with PLC programming, visualization, whatever it might be. If we keep scrolling down the page here, we've got links out to our C-Train web-based trainings for TIA Portal version 16. Version 16 is our latest version. It came out in December of last year. And here is some web-based trainings on some of the new topics around the TIA Portal version 16. Such as like, you know, the SIMATIC WinCC Unified panels maybe. So if you do face some downtime right now, maybe clicking on here and checking out some of our web-based trainings from C-Train would be a really good starter. Continuing down, we then have a breakdown of all the really cool application examples, FAQs, and the likes are available for the SIMATIC S7 1200s and 1500 ranges. Some of the FAQs and application examples that I'll be looking at today are things like this one here, which is our library of general functions for the S7 1200 and 1500. So basically a ready-made set of application code for commonly required tasks within inside of the automation portfolio. So whether that's through data handling or math operations, as you can see here, there's no need to reinvent the wheel in some cases. Siemens has already produced these software blocks which you can download, put into your install of your automation software, and utilize, ready to go. And I will show you some of these in the demonstrations later on. But the reason for this morning, and the main link off of that other one, is this one, which takes you to the page on our programming guidelines and style guide for the S7 1200 and 1500, which are of course our current innovative controller platform. The S7 1200 launched around 2010, 2011 into the UK, and the S7 1500 came out in 2012. So been around for quite a while now. But the document that you can download from this page is available to give you the programming guidelines for whether you're doing standard application code and also safety application code. So you can get tips and hints on how to optimize your PLC code for this. And as you come down here, you get further downloads to things like the style guide checker, which I'll show you in just a moment, and also some ready-made templates. If you want to write your application code in a standard like PLC Open, as an example, as the standard, here are some ready-made templates for you to use when creating your own functions and application codes. And ultimately, why am I focusing on this right now? Why do I want to highlight these things to you? Well, for us, the destination of automation and application code within this platform is very much code is going to write itself based on other sets of parameters. So whether that's like today, where you could harness the power of TIA Portal openness to write your own tool to automatically generate your application code or modify your application code or do consistency checks, whatever it might be, or whether it's a case of you go and use some of the tools again on CEOS, like the SIMATIC Modular Application Creator, which again can create ready-made application code for PLCs and HMIs based on standard library objects, or whether it's you purchase off us the Digital Industry Software's Automation Designer tool, which automatically generates your PLC code based on the CAD data of your machine or your electrical data of your machine. All these function blocks that you create would need to be written in the most optimized and standardized format to allow them to automatically be bolted together or automatically scaled up within inside of your application. And that's pretty much why I'm wanting to take the next 20 minutes to go through these sorts of things. If you are interested in standardization moving forward, and hopefully we're all interested in standardization moving forward, again, we've got a fantastic, I'm not going to go into it now, but a fantastic document available to download from the support site, which I can briefly show you here. This is the standardization document, which briefly covers some of the key areas of standardization within here, the sort of standards, the industry standards you should look to follow when creating your application code. And then as you can see here, it's referencing the programming guidelines and style guidelines for the controllers, because this is the fundamentals, the basis of your design code for when moving forward with standards. So I've mentioned it enough. Let's go have a look at it. This here is the programming guidelines for S7 1200 and S7 1500. And honestly, it is a fantastic document to go and read. And if you've got time right now, I cannot recommend it enough. Even if you were new to the S7 1200 and 1500 platform, but had lots of experience in our previous S7 300 and 400 platform, it's also a very good document to read, because we do run some comparisons, to show you how things have changed from what it used to be in the legacy world of SIMATIC Manager and what it now looks like in the current platform of TIA Portal, from the programming innovations to how the actual programming languages that are now available to us. In particular, structured control language, SCL, is now available as standard in the S7 1200s and 1500s, and I am going to be touching on the SCL language in the live demonstrations. But also it talks about optimized machine code, so how the compiler is now different to the 300s and 400s. So even like code from a 300 can potentially run faster in a 1200 or 1500 with the same performance spec, just because the machine code layer has been optimized due to things like optimized blocks and symbolic access and the likes. But all this information is covered within inside of this document, and I do strongly recommend giving it a read. As I said, we also then do have the programming style guide checklist as well. And this is a fantastic tool. Whether you're maybe a system integrator and looking to have a value add to your customer to say, hey, I've written this application code, but it also meets the requirements as specified by the manufacturer, or whether you are the end customer receiving a machine that has a SIMATIC controller inside it and you want to know it has been programmed to the best of its ability, then this document is a great one. It's an interactive document, so as you scroll through the checklist, it gives you the ability to populate it with who you are and what various information the particular project you are doing. But yeah, it is a checklist. So you come down here and it's listing all the different rules that we have, and you can just go through and say, yep, I did meet this one, I did meet this one, I did meet this one, or maybe this one wasn't relevant. At the end of the document, it gives you the ability to detail which rules you didn't meet, why you didn't meet them, and any corrections that you made to overcome this sort of thing as well. So fantastic value add document in terms of handing over, a system that's been programmed with SIMATIC to the end user. Okay, so diving back to the guidelines document, if we have a look at Chapter 7 here, we can see it's conveniently titled for us, the most important recommendations, and it's pretty much these important recommendations that I'm going to be running through for the final 25 minutes of this webinar this afternoon. So if we look through here, we've got some important ones like make sure you're using optimized access or optimized blocks to ensure that you're getting the most out of the memory resource within the controller. Of course, programs should be structured well and clearly and commented and the likes like this. It talks further right to the very end here where it even says things like no more use of bit memory, but use global data blocks. So moving away from the classic use of marker words or memory flags, whatever you like to call them, but actually using data blocks instead to ensure modularity in your application code and allow it to be transferred to different applications. One of the biggest changes, though, that came with the S7 1500 and 1200 was symbolic addressing. Like I've said many times, the memory is optimized, and we now encourage that you program completely symbolically. Don't worry about data block numbers, address areas, and the likes of this. Just work symbolically and let the compiler deal with where it's going to be storing all these individual bits of information. So as a starter, I would like just to focus on symbolic access and show you a few tips and tricks around that. So I'm firing up TIA Portal in front of me now. This is TIA Portal version 16, which is our latest release. And you can see here I've got a little project with my PLC and some I/O drive and some ET200SP, all nicely named with meaningful names, which of course feeds into our automatically generated diagnostics. So in terms of symbolic addressing, what does that mean? Well, if I just quickly open a tag table here, it means I could have an input which might have a real address of input word 0 as an example, but maybe I'd give it a real nice symbolic name like drive status, because this is going to be the drive status word coming back from my drive sat out on Profinet. But this, of course, has been defined as a word because this is how the drive passes it back to me. What if I wanted to look inside this word and see the individual bits and bytes within inside of my application code? How do I go ahead and address those? Well, within inside the SM 1500 and 1200, we have something called slice access to allow you to do that. So if I insert an instruction here, which is expecting a Boolean type connected to it, and I go to my tag table and I bring in my drive status, clearly this is going to go red because this isn't the right data type, so it doesn't like this configuration. But if I want to just get a bit within inside this, slice access allows me to do that simply by pressing dot after the tag name, and then doing something like x0 allows me to access the first bit or bit 0 within inside of that word. And we could do this for any bit within inside of here, so we could do x9 as an example to get at the 9th or the 10th bit, depends how you look at it, bit within inside of this particular word. We can also do not just a Boolean breakdown, but we could break the word into its individual bytes. So again, I could do drive status here, but to get a byte, I go .b0, and that will give me access to the first byte. And again, if I wanted to get access to the second byte, then that would just be a case of doing .b1, and then we're looking at byte 1. Of course, this is just a word, so this is as far as we go, But if I defined a tag that was a bit bigger than this, like a real or a double or something like this, then I could do .w to gain access to the words. If it's bigger, I could do .d to gain access to the doubles within inside of the larger data types as well. So slice access is fantastic. You can use it like this in its raw form against tags, or if we were to dive into, let's just do ladder for the minute, dive into a function block. If we had an input here, again, let's call it status, which is the status word coming into my function block. You can, of course, still do this within inside of the within inside of a function. So we got status dot x0 to gain access to the first bit within inside of that status word. However, this, of course, is fantastic, but this part here now isn't symbolically being addressed. We're now looking at things absolute. We're looking at bit 0. And what does bit 0 mean to me when I'm looking at this application code? Well, it doesn't mean anything. There is a way, though, of providing a symbolic access even to the individual bits and bytes within inside of this larger data type. And this comes when we're inside of function blocks, and it's something called AT construct. So what I just showed you here was called slice access, and what I'm going to show you now is AT construct. So our input here could be a status word. So this is the status word. Let's pretend it's still from my drive. And maybe within inside my status word, I then got those different booleans. So to break it down with AT construct, I can define a new tag underneath status word, which we'll just call status for convenience. And then we just type AT, which gives us access to the AT construct. If I hit return, you will see now that I only have the one connection defined. This one isn't a new input. This one here is the AT construct that's been overlaid on my status word. So status is an AT construct of status word. Right now, this is just defined as word, so it's giving me the maximum amount of data that's available. But I can simply change this to struct to allow me to overlay a structure on here. And now I can have my different booleans symbolically named within my structure that's being overlaid on this status word. So like running, error, I don't know, warning, something like this. Maybe there's then some spare, that was a good one, I did an exclamation mark. Maybe there's some spare booleans that are in here. Forgive me if I got the wrong amount of data now, but then maybe the last one is status byte as an example, byte types. But effectively, I've now got a complete structure defined that's being overlaid on that status word, meaning that within my application code, I can now address this completely symbolically from the header information within inside of my function block. As far as the function block looks like when it's called, if we do call it, there we go. All it's expecting is that one connection, which is my status word. All that symbolic overlay with AT construct is solely contained within inside the block for use within inside of your programming. So this is a really cool feature when putting these blocks together. However, if we dive back to the programming guidelines for a moment, you'll notice that one of the instructions here is here. Ooh, I can't highlight. There we go. Creating PLC data types. So what this is saying here is actually in the guidelines we recommend you don't use the data type struct inside of your programming. If you are using struct, then use a data type. Create the data type and use that instead of ad hocly creating these structures. And there's huge benefits when you do start using data types rather than structs. So this is quite nice. If we were to go back to my block then and say, okay, I don't want to be using this struct, I now need to use a data type here. Well, just to bring us back to the support site for just 1 minute, another useful download is the library of PLC data types. So we actually provide a fully made library ready for data types that tie up with hardware within inside of our portfolio. So you can see here there's some data types made for the ET200 MP, the ET200 SP I/O solutions, as well as one here you'll notice called ProfiDrive. So within inside this library exists all the data types for ProfiDrive. So all the different telegrams, you can see here, telegram 7, 9, 20, 82, 116, all the different ProfiDrive telegrams, all the data types are already made and available to download directly from CEOS. I've actually copied some of these into my project here. So if we go look at PLC data types, you'll see I've copied in some data types from the library. So this means within my little block I was writing, if this actually was a drive status, then I can just simply say, give me the data type of status word 1. And now within my application code, I have the Profi Drive Telegram status word 1 being fully overlaid on that status word, which is quite nice. To take it back to where we started, which was in the tag table, you can also overlay this on your I/O as well. So if I go back to my configuration, you remember I have a drive within inside of my project. If we look at the drives configuration here, you will see that I am using Telegram 350. In terms of getting data from the drive, it's at address Q256, and sending to the drive is also at 256, but sorry, I did that the wrong way around, but on the input is 256. So we know it's Telegram 350, so that means now I can literally go to my PLC tag table. I256 was the address, and the data type would be the data type off of the Siemens support site, Telegram 350 inputs. There we go. So we can call this inlet pump in as an example. And now, just by tagging up that one tag, my complete status word for the drive can be fully symbolically addressed within inside of my application code. So this is great for applying these data types over I/O cards, RFID readers, whatever it might be. You can just apply these data types directly over your input area. But you can also use it for doing communications as well. So if I just quickly add myself an S7 1200 maybe into my application, people I see even now still use put and get as the most commonly used protocol for doing S7 to S7 communications. Of course, if we're looking to use put and get, we have to turn off one layer of security that's built into the SIMATIC controllers to allow some random thing just to be putting and getting data out of the controller. So a better way of doing this would be by using Profinet communications instead. So let's say my application, I've now added an S7 1200. Maybe this is controlling the heater on my tank with its integrated PID control. If I wanted to send feedback to the main controller of what's occurring, then we can come into the configuration of the 1200 here, and we can just say it's an I/O device, and it's going to be reporting data back to the tank controller. And now this is just going to be treated like any kind of I/O within our application here. In terms of what the I/O area looks like, we just define it down here. We could have a transfer area. We could call it status maybe to feedback. It is going to be a input to the I/O controller, so we can see it's defined as an input, and we can define how many bytes you want to send. So let's just say, for example, we want to send 10 bytes. Within this table, we can see how the addresses are broken down. So in my 1500, it's address input 36, and in my 1200 here, it's output address 1 is where the data is going to be being sent to the 1500. So again, we can address all of this symbolically. So within inside my 1200, why don't we go ahead and create ourselves our very own data type? So we could call it heater status as an example. Maybe we've got set point, actual, heat on, cooling on maybe is something different. You have to forgive all typos I do on the fly. And then we could also have like error and status word, just to give us some different data types. So here we go. This is a word, and maybe these set points at the top here are fields. There we go. So this is now my data type for the status of the heater, which I want to send back to the 1500. If you remember in the configuration for the 1200, it was output address 1. So for us in the 1200, we can just go to our tag table. We can go to that output address. I always type this in first because I'll quickly forget it. But the output address is 1, and we can just apply the heater status data type to it, and we can just call it feedback as an example. This is what the 1200 would want to know it as. This is my feedback area, and now it overlays that data type onto that output. As far as the 1500 goes, we can copy that data type directly out of the 1200 because these are made of the same stuff. So we can copy from the 1200, and we'll paste it into the 1500. So I now have that data type available to me in the 1500. Of course, we're not covering it today, but of course, if this was sat within my library here and I was centrally managing and controlling it within my library, if I was to update these data types, it would automatically update it in the 1200 and the 1500 in one go. I wouldn't have to do any more copying and pasting because the library can manage the version control between the two devices. We're not covering that right now. But yeah, in the 1500, I now have that data type available to me. If we remember, the I/O in the 1500 was input 36. So we can go to our tag table, input 36, and it's going to be heater. And maybe this is the feedback from heater 1 on my tank. And now I have complete symbolic access to all the data that's been sent to me from the 1200. I'm not calling any other function blocks to put and get this data. It's just automatically happening for me as part of the Profinet setup on these two devices. So data types are fantastic, and you can overlay them on the address areas just like this, but of course you can use them with inside your applications as well. So as an example, why don't we go ahead and create ourselves a data block here for heater data, maybe, and we could put in here heater number 1, and it's going to be of data type heater status, and maybe we have several heaters which are going to have the statuses being saved for. Again, we've got that structure there with inside us. What's nice is when you are using data types, you can move data just as it is within that structure. So as an example, we'll go back to a little bit of code here. We'll bring back in a move block. And if we wanted to, we could be saying, okay, get me the data from heater 1, which is all the data from heater 1. There we go. Coming off the 1200, input 36, if you remember. And then just go store it within that data block. I've highlighted that data block. Here's heater 1, storage area, maybe in a DB, and there we go. So now it's moving the data from the input directly into there. And it can just do this because it's a structure. So structures can just be moved from one place to another. Of course, I could just do this from 2 different structures even. So let's just, for a bit of fun, move the data from heater 4 to heater 5. There you go, just to show you that it doesn't have to be from input areas. It's just data in structures. In PLC data types, more to the point, can just be moved quite easily and simply from one place to another. So this is another cool reason for why we should be using PLC data types rather than a struct definition, which wouldn't allow you to do this. Okay, going back to our PLC data types, though, our PLC guidelines. Another tip it says in here is that when you're dealing with data, though, so when you're handling data, you should work with array as the data type, the overall data type, if you like. And this obviously applies to where I was just configuring my application a moment ago. So if we go back to my data block, here I just have a load of heaters that have been independently created with inside of my data block. If I need another one, then I've got to go and manually do all these drags and stuff to add some more elements. But as per the guidelines says, this isn't the best way. The best way for us would be to say, well, let's create ourselves an array. And the array would, of course, be of heater status. This now means that I can simply scale up and down my application by changing how many elements are going to be within inside my array. If I now set that as 10, then we've now got 10, let's rename that to a better name, 10 heaters, or 11, because this is 0, being created for us. So once they're in this form, it allows us to do a lot more when we're processing this information within inside of our application code. And this is where I'm now going to show us a bit of SCL, because SCL offers the best when manipulating data that is being stored within inside of an array. So let's add ourselves a new block. Let's go SCL. Here we go. So this is SCL. It's structure control language. So it's a language-based programming, and it is fantastic. It's fully optimized and one of the best languages for using with inside of our controllers. It is text-based, like I said, so you get a little favorites bar here, which can give you some code snippets. So here it's got things like if statements or case statements. So if the variables equal 1, do this. If it's between 2 and 4, do this. This sort of thing. And of course, we've got the great for do loops which, as you can imagine, are very useful when it comes to manipulating arrays. You can see all this, you think, oh, there's loads of text, this is quite hard to read. SCL offers some other fantastic features to help you read your code, like regions. So this allows you to group areas of code with kind of like reference names. So perhaps you can have a region here called initial, where some initial bits of code is going to happen. Perhaps you can have a region here called main, and perhaps you can have a region here called error handle, forgive all typing errors, error handling. And if you want to, we can even put regions in regions. So maybe with inside main, we have something called, I don't know, startup, and maybe, I don't know, motor control, could be anything. So you'll see that by putting these regions in, it allows us to collapse bits of code within inside of the viewing window here, so we're not overwhelmed by line upon line of text. But it also gives us a little pane on the left to quickly go to where we might want to go with inside of our application code. So whether we want to go to the error handling, or maybe with inside of main, we want to go to motor control, it'll take us directly to where this part is located within inside of the application code, which is really nice. Another cool feature that SCL has is the ability to turn on and off snippets of code within inside of the application. So maybe in your ladder world, you've put on a contact and you set it to false, so then it prevents some calls of blocks occurring further within the sequence. You can do this within SCL too, simply by highlighting the bit of code you do not want to call and just clicking the toolbar icon here to comment it out. So if we click that, that now comments out the application code. So if we were to download that into the PLC, that isn't going to run, it's just a comment, but we haven't lost the bit of code. It's still there if we want to bring it back in at a later date. To do that, we just highlight it again and say remove the comment. There we go. And then my bit of code is made available to me again. There's so many cool features within SCL, and yeah, if you go look at the programming guidelines, it covers quite a lot of them, and there is also some other application examples and getting started is available on COS as well. It's got things like breakpoints in there as well, so if you are using for do loops, which you're going to look at in a minute, and you really want to deep dive into why something isn't working, then breakpoints are really useful for doing this as well. But we're looking at how we can handle arrays within inside SCL. So let's bring our array into this, and we'll define it like we did within the data block, where we have an array of 0 to 10, and the data type is meat. So let's just put that for a second, and change the data type to heater status. There we go. I've defined it as an in-out, which also is as per the PLC guidelines. When moving big parts of data into a function block, you should use the in-out because then it's just a pointer back to where it's being stored rather than recreating it inside of the block. So in my block here, let's pretend I'm saying, okay, I've got this array. I've got these 11 heaters, 0 to 10 being passed in. I want to find out if any of them has got the error bit set. This is quite easy in SCL. We can say, okay, if error, so if this bit is true, then execute this bit of code. I'm not going to write the code right now to do that, but there we go. This would do that. Of course, to do this for element 0 in the array, 1, 2, 3, we're not simply just going to copy and paste this instruction several times. We're going to take advantage of the for do loop, which allows us to provide it with a data array, which will be our counter. It'll count between two fixed numbers, and you can then use that within inside of the loop to manipulate things. Let's go ahead and define ourselves a counter, temp I. This is going to be an integer. So we can say, here's my counter. There we go. And we know the array starts at 0. We know it ends at 10. This is what we're going to do. We're then going to get my if statement and drop that in here. So now we're saying from 0 to 10, execute this. Of course, we then need to change where we're looking at the array. We're not looking at a fixed element anymore. We're now looking at where we are in the counter. So this will ripple around this loop 11 times, 0 to 10, and each time it'll be either 0 coming in here, or 1, or 2, or 3. So you can see within just 4 lines of code, I'm now able to process 11 heaters to find out if any of them has an error, and then go ahead and manipulate that in some way. In terms of how we call that block, let's get rid of these error things. we would just say, here's my block I've just written, and we can simply then get the heater data, which is my array, and connect that up. This is absolutely fantastic. However, the guidelines also state some things about arrays as well. So one of the things it states is when you define an array, you should define it as from 0 to constant. Now, Plc constants are something that's only available in 12 and 1500, but this allows you to define a value that can be used throughout your application code and can't be changed from within your application code. So where these are set is within the tag table. So if we go back to our Plc tag table, you can see we've got our tags in this tab here, and on the second tab across, we have user constants. So we could have a constant, as an example, called number heaters in integer, and it will leave it as 10. So here we can see we have a constant value set as 10. We can then go ahead, I'm just going to copy that, and use that within our data block declaration here to say rather than be 0 to 10, now be 0 to number of heaters, my constant. We can see it's 10. Of course, if I go back to my tag table, change it to a 5, go back to my data block, I now have 5. So this is a fantastic way also of scaling up and down your applications. You know, many times you see people define an array which is a buffer for storing information, and then maybe they hit the limit of the controller they're in because the buffers are now too big and the controller's not only got a certain amount of memory. Using constants when defining array means you can literally come here and tweak the size of the application in a couple of clicks within the user constants, and all the application changes are then happening in the background. However, through using the constants like this with arrays, we can run into some challenges which you should remember when programming. So right now, if you remember, I've got my function block and I've got it connected to that bit in the data block I'm currently scaling up and down. If you remember, when we created this data block, I defined the array on the in-out, and I defined it as an array of 0 to 10. So clearly we're going to face an issue if I now say my constant is 5, which now changes the size of the defined array within inside the data block, which means my PLC code is going to not be happy because the function block wants an array of 0 to 10, but I am providing it an array of 0 to 5. So this is no good. How do we overcome this? Well, the obvious one would be to say, oh, I just need to take that same constant and put it inside this function block here. So where I've defined my array as an example, I'll just put that constant in there. There we go, number of heaters. And yeah, sure enough, if we go and update this block, this now fixes the issue because the array that it's expecting will scale with the array that's outside of it. However, this isn't best practice programming here. And we know it's not best practice programming because if we were to compile the function block I've just written to find out if it conforms to our library standards, which we can do by going to the properties of the block, we can see down here, library conformance, warning, it does not comply because it's accessing data that is external to the function block, in particular this constant. So what this library conformance does is basically it allows you to know whether your block is modular, whether you could easily move it from one application to another, or whether it is referencing things specifically that are outside of it, which means it isn't going to be very easy to move it from one application to another. So we need to overcome this warning here to make sure that we don't get any kind of issues. So one way of doing that would be to say, okay, I'll take that constant and I'll put it inside the function block. So with inside function blocks, you can define constants. We'll just call it heaters, integer, give it a 5, and the same thing applies. So you can just put that up here. And now, great, my array is now scaling. And if I compile the block, it meets the requirements of the library. Go to properties. It's now meeting the requirements of the library. However, this is okay. It meets the library conformancy, but it's not great in terms of programming because now every time I change the user constant within the tag table, I'm going to have to come into this function block and change this constant as well. So there are ways around this. Before I do that, though, just to show you where constants are pretty cool with inside of these applications is with regards to scaling up application calls inside your blocks. So as an example, I here have a for do loop that I was using to do that find me an error. Let's just get rid of that for just a second. What we could do is actually put instance data of functions within inside of my headers here. So let me just show you. If I was to call this function block within inside this function block, it needs instance data because it's a function block. Making it a multi-instance means that this instance data will sit within inside of the header of my function. Here it is. But we can actually put this inside of an array as well. Let me show you. So we can go array of block 1. So now, rather than this block here, using the static area that was defined previous, if we just call it again, we can say use some multi-instance data, use one that's already existent within inside the block from array element 0. There we go. But of course, we're doing it in 4 do loops. So we're saying we don't want to just call that one block with array instance 0. We want it to be as per the counter. So again, we can just get our temp value here, drop him in there. There we go. With regards to how many times we're going to call this block, well, we could just use the constant. So we could call this block calls, and then we can put block calls in the definition of our array. There we go. And we can put block calls within our code. So within just these 3 lines of application code, I'm now calling a function block however many times I want to, dependent on the value defined in constants. This is really cool if you're doing stuff around motion. You want to scale up and down maybe the queue for commands going from a PLC to a robot or something like this. But yeah, it allows you to completely scale. Cool tip. Anyway, to pass that to one side, we were looking at what we can do with this array. And ultimately with this array, we can say, well, you know what? We're going to have an array. It's going to come into this block here, but it's going to be of unknown size. So you can basically define an array with no size within inside of this application. What does that mean? Well, if we go back to our block and we give it a good old update, it means that now we can connect anything to it, an array of any size. You can see here it's expecting an array of any size. So whether our heaters is currently set at 5 or whether it's set at 100, go back to the OB, it'll be quite happy in terms of taking that array without any recompilation or changes within my function block. So yeah, that's cool, but I'm passing an array of unknown size in. How do I actually use an array of unknown size? Well, the first thing you need to do is find out what its size is. So let's give ourselves some more values. Temp upper, temp lower, and we can find out how big our array is. So we can say the upper limit of my array is equal to upper bound, a ready-made function. It's just a standard instruction. We can say find me the upper bound of my array in the first dimension, and we can also say find me the lower bound within my array, and again within the first dimension. And in terms of how my for do loop would look, I'm just going to be saying from lower bound, from lower bound to upper bound, go ahead and do whatever we're doing within inside of my application. A completely scalable function block that can take an array of any size, which now means that my applications can be scaled up and down depending on my customer's needs, and I don't need to go and make any changes to my application code. Because it's universal in terms of its access. So this is a cool feature that we can use for dealing with arrays, and a bit on SCL there. Finally, to really get to the super advanced stuff, if we weren't going advanced enough just there, the final point that comes into the most important recommendations here is the use of the data type variant instead of array. So variant was a new one we introduced with the 1200s and 1500s. Basically, it's saying you can have any, but we had to rename any because we already had any. So variant, you can vary the connection that is coming in or the data type that's being used. So what does this look like for me? Well, it means that inside of my application here, I can say, well, rather than me saying I have an array of heater status, I can just have a variant. This now means I can connect absolutely anything to this in-out pin on my function block. If we go back out here and just update the block call, we can see if I hover over it, it's expecting anything. Absolutely anything can be connected to this block. Of course, if we're connecting anything, we're going to need to know what can we do with anything. So we have to find out what it is. And this is where we get a standard function called type of. You can see here we can have type of, and we can bring in this. And this will now return to us what kind of type it is. So if you want to, we could say, let's have an if statement. And we could say if type of my array is equal to an integer, then do this. There you go. Integer is a keyword inside of SCR. If you were doing this, though, to find out, you wouldn't be using the if statements. This is where the case statements come in really quite nice, because you can actually do this as a case. You can say case of my data type, and then rather than numbers, we're now just doing data types. So this will be type of integer, or we can have down here type of real. And now we'll be processing that data dependent on what the type is that's coming in. If you wanted to compare it to a type that isn't a standard one, like int, word, real, etc., etc., you want to do your own one, like we were, heater control, then you'd have to have that type defined for it to compare with. So here we could say I have a temp, I don't need this data, my type, and this is going to be defined as heater status. So if I do my if statement again, I can now say if the type of this input output equals the type of this defined one here, then I know that is going to be the data type I'm expecting, and I can process it in a meaningful way, so forth. Of course, this is me looking at just the raw data type. If it really was an array, you would have to use functions like is array to find out if it's an array, and then inside the array you can do a type of elements to find out what the elements are within that array when you're using this variant data type. And that's kind of where I wanted to leave it for today. I hope that was of interest in terms of going through the guidelines and the best practice when using the SIMATIC controllers and some of the innovation we have in this platform that segregates it from our classic controllers. And yeah, if you take advantage of some of these innovations I've shown you here today, you can really optimize the running of your application code and the scalability of that code, making it more flexible for reusability into other kinds of applications as well. But at this point, I thank you for your for your attendance and attention. I will now be closing down the recording, and if anyone has any questions, you are then welcome to ask them. Else, thank you, and enjoy the rest of your afternoon.